in your book, first of all, this is not chapter 6. This is chapter 4. Sorry, I forgot to edit. All right, so we're basically looking at quadratic equations. Okay. So what this is going to look like when we graph it. So first, know the important parts of the graph. So like you guys said in the math moment, that shape that you saw was parabolic, okay, because it was kind of shaped like that arch, okay, or like a U. And there are some important things that we want to know about the parabola, things that stand out to us, and we either know now why they're important or we're going to see why they're important and what part of the equation kind of contributes to that important part. So the point where it turns around, just like in an absolute value function, we call that a vertex point. So you're going to call vertex points in lots of different shapes. So every time they kind of have that turnaround feature. Through the vertex point is the axis of symmetry. Just like in geometry when you guys experienced symmetry, okay? It's dividing your graph in half. If I folded it there, I would see the graph sit on top of the other portion of the graph. And then notice the last thing that's been pointed out to you in green here. Graphically, they are x-intercepts because it's the place where the graph is crossing the x-axis. But you have to understand that in quadratic language, those x-intercepts serve many different purposes. So you're going to hear them referred to in lots of different ways. And whether you're dealing with an equation or a graph, you have to be able to interpret them correctly. So they might call them x-intercepts, which visually we understand from the graph. They might also call them roots, zeros, or solutions. And we'll get more into why they would call them any of those things later on. Okay? I can just go. No. Didn't work. All right. Okay, so the first form of the graph that we're going to look at is standard form of the equation. So notice standard form, and I didn't write y equals, I wrote f of x equals. Get used to the notation, be okay with the fact that it represents a y value. And on the other side of the equation, you see ax squared plus bx plus c. So how many of you guys remember this is how a quadratic looks? Okay, you've seen a, b, and c in those spots. Good. Okay, at least half of us. Now, how many of you guys recognize what's in these green boxes right here? Okay, what is that? What do we call that? Quadratic formula. And quadratic formula solves quadratic equations for you, right? So that's been noted in these spots because what did we call these points besides x-intercepts? What was one of the other names? Solutions. So one of the ways to get those points would be to solve the equation using the quadratic formula. Okay? But then I want to point out is how we have labeled the vertex and the axis of symmetry. Okay? Notice that at the vertex point, the x-coordinate, and at the equation of the axis of symmetry, which notice says x equals, why does this line, this red line marked on the graph, say x equals as its equation? Huh? Mm-hmm. Okay, good. So vertical lines that cross through that same x-coordinate, right? Their equation is x equals because along the line, every point is going to have that same x-coordinate. It's going to be unchanging. So remember, vertical line has that x equals equation. Now, where the heck did this negative b over 2a come from? Huh? Yeah, that's okay. Mm-hmm. Yep. Yep. So remember the quadratic formula has a plus or minus in it? So notice this one's using the plus and this one's using the minus. So when you solve something using the quadratic formula, some of the time, you use both the plus and the minus. And when that happens, that means there's two answers, one from the calculation with the plus and one from the calculation with the minus. Okay? So how many of you guys have seen the negative b over 2a formula before? Okay? And you knew that it helps you find something to do with the vertex or the axis of symmetry? How many of you guys have any idea why they came up with negative b over 2a as the formula for that? Helen? Okay, so it does happen to be the quadratic formula without the radical, but they didn't just say, like, let's take away the radical part and make that the formula for the vertex, okay? They don't make up math like that. But what is the relationship between the points that the quadratic formula found, the solutions, and the vertex, or the axis of symmetry? What do those two solution points and that axis of symmetry position have as their relationship? Raymond? Okay, so if we looked at the 2 points, they can cancel each other out if we added it together, because there would be a negative radical and a positive radical. Okay? Good. So since our parabola is a symmetrical figure, hence the axis of symmetry running down the middle, correct? Then any 2 points on the side of the parabola that are like at the same level, they have to be the same distance from that axis of symmetry, right? Or else it'd be like a lot weirder shaped than just like this simple parabola. So if you want to find the number that's exactly in the middle of 2 other numbers, what arithmetic do you do? Like, let's say I pointed on the number line at 10 and 8. What number is directly between 10 and 8? 9. We know that because we know how to count. But how mathematically could you do something on a larger scale to figure that out? Bailey? Good. You find the mean, or the average. If we find the mean with the quadratic formula, okay, what does finding the mean entail if there's 2 numbers involved? What do you do with the 2 numbers? You add them and divide them by 2. So think about taking those 2 really large, crazy-looking quantities from the quadratic formula. Think about adding them together. When you add them together, they have the same common denominator. Negative b plus negative b would make negative 2b. And that giant negative radical with the same giant positive radical would cancel out. So they didn't just take the radical off. They averaged these 2 solutions together to find what was in the middle. And when you start doing this process, they cancel out. Now, right here, it looks like we would get b over a instead of b over 2a. But all I've done so far is add them together. What do I need to do to finish my mean calculation? Divide by 2. So if I have negative b over a, and I'm dividing that by 2, which is the same thing as multiplying by 1/2, I'm going to get negative b over 2a. So someone didn't just make up a random formula to give you and say, start every time when you graph a parabola and do negative b over 2a. Okay, instead, it all fits together mathematically about all the way that the quadratic formula works. So this is going to be some number every time you guys do this calculation. I just wanted you to know that the formula didn't just like come from thin air or somebody dictated that you had to use it. It all works together. And so this same number that you're getting for the x-coordinate of the vertex, it's on the axis of symmetry, so it's the same number that you're using in your equation for the axis of symmetry. And when you look at the y-coordinate of the vertex, okay, anybody want to translate for me what this means? F and then parentheses negative b over 2a. Really? Good. It just means a y-coordinate. Specifically, the y-coordinate you would get from the equation f, which is what we called our equation up at the top, right? When we plugged in what? This x value, negative b over 2a. So don't be confused by this crazy, like, notation. It's just saying go back to f and plug in that x value you just figured out, and you'll have the y-coordinate also. Okay? So in standard form, this negative b over 2a is a really useful formula. There are other ways besides the quadratic formula that we can find the solutions. I just wanted to demonstrate those here so you could see where that negative b over 2a came from. Cody? And then that. So you don't plug in anything for f. F is just the name of the function. But when you see f written and then you see something written after it, it means plug this into the f function. So if this said like f of 2, it means you would take 2 up to that function, plug it in for x, and do the calculation on the right-hand side. So this is just saying plug in whatever you got with this calculation right here. Okay? Yeah, Matt.
Is it possible to have the parabola, but it's on top of the x-axis?
Yes. So it is possible that we don't get 2 solutions. Sometimes we might only have 1, and sometimes we might have 0, and we'll look at those situations as well, just to give you guys an overview. Claire?
Does f always apply to y, or is that just...
F applies to the y value of this function because we called it f. Somebody could write an f, a g, an h, a k. They can use whatever letter they want, but it's always like that side of the equation, the y value, just whichever equation matches up with the letter f. Okay? Helen?
So for the point that it's showing in the box,
Uh-huh.
when it says like f and then that value,
Uh-huh.
Does it mean like the sum of like the whole function or the x?
Yeah. It means the y value when you've plugged in this x value. So f of something means y, but specifically the y when you plugged this special number in the parentheses in for x in the equation. Okay? Yes?
So normally like when we're doing a problem like
Mhm.
that standard form equation, like there will be numbers there for A.
Yes. There will be numbers there for a, b, and c.
And then we just like plug in B and A there. Once we get that, we can plug it in for X.
Yes. So what she's saying is when you get an equation in standard form that you're actually expected to calculate something for, there would be numbers in the a, b, and c spots. This negative b over 2a formula that we now understand where it came from will give us this very important x value of our vertex and where our axis of symmetry is. And let's say it came out to be 3, just because it happens to look that way on the picture. Then we would take 3 and we'd plug it back into that equation with all those other numbers, and it would give us the y coordinate that goes with our vertex. Okay? Matt?
Is it possible to have like a negative parabola?
Yes, it's possible to have a negative parabola also. And we're going to see all those different things. Just like we saw with absolute value, we're going to do some graphing stuff with those. All right. So another form that they might write your equation in for you would be factored form or intercept form. Notice in this specific factored form, like the a got factored all the way out. Like there was some number factored out, so you're just left with two very simple factors that have x in them. When you guys factored in Algebra 1 and then you set them equal to 0, do you know what you were doing? Or were you just like, I set them equal to 0 because they said set them equal to 0? Yes? Okay? All right, what you were doing is you were solving the quadratic. So it's like setting this side equal to 0, and you have things that multiply to make 0. Now, if I came in the classroom and said, I'm thinking of numbers in my head. When I multiply them, I get 0 as an answer. What would you know about the things I'm thinking of in my head? Alex? Yeah, 0 has to be one of the numbers that I'm multiplying together, right? So that's why, if this is set equal to 0, you would go and you would set those factors equal to 0. Okay? Now, x minus p, p is the place where the number would be, and x minus q, q is a place where the number would be. Okay, so if it was like x minus 2, and you set that equal to 0, what would your solution be? So what do you get if you take x minus 2 and you set it equal to 0? X comes out to be what number? 2. Okay? If it was x minus 5 and you set it equal to 0, what does x come out to be? 5. Okay, if it was x plus 3 and you set it equal to 0, then x would be negative 3. So the idea here is if it's factored already for you or it can be factored, that's a really quick way to find these two numbers that before we might have had to use like the quadratic formula or something like that, right? So we can get those numbers a little faster this time. Notice it just says p and q, like whatever you get when you set them equal to 0. Cody?
So does p represent the first number to the left or like a negative number?
P represents whatever number was right here, like as this said, x minus 2, and you set it equal to 0, p is 2, right? Then that's what p is here. Okay? P could be a negative number, and then it would have turned into like plus. It's just saying there's a number, okay? But we're doing it in a very abstract sense. Alex?
This is kind of crazy, but
Mm-hmm.
if they give us the axis of symmetry,
Uh-huh.
we work backwards to find the two x-intercepts.
You can't just work backwards from the axis of symmetry because you'd have to have some idea of how wide the parabola is. So there's some other things in the equation you would have to relate it to. But so in this case, if we use our factors to find our x-intercepts, okay, just like we did with the quadratic formula, once you have 2 points on your parabola at the same level, how do you find where that axis of symmetry is in the middle? Huh? You find the mean. And this time, the formula is not as complicated because p and q are just these two numbers we came up with. We would add them together and divide by 2. Okay? And you'd get a number, right? We just don't have numbers in the equation right now because we want to say you can do this all the time. So we're using variables. But so you would add them together, divide by 2, and you'd find what's in the middle. So that means x coordinate of your vertex and the number you're going to use in your axis of symmetry equation. And then how do you figure out the y coordinate of your vertex? Plug it in. Whatever you got for the x coordinate, go back up to your equation, plug that in for x, calculate all the numbers, and get the y value. Okay? So same kind of sense. All right, so the last thing we're going to look at is if it's written in vertex form. Okay? What does this remind you of? Yeah, what does this look like, Eric? It looks like the absolute value, but it only looks like the absolute value because that's the only place you ever saw a math teacher put in A, H, K in these spots or whatever, right? But remember how we talked about transformations, and you guys did homework last time on transformations? What we want to do is not make you learn something just for absolute value and something just for quadratics and something just for every other type of graph that exists, because that would be a lot of somethings that you would have to file away in your head, right? Instead, we want you to learn that the graphs start with a basic shape. And yeah, you do have to know that absolute value looks different from a quadratic, looks different from everything else. You have to know that. But those A, H, and K values that you saw before, they're very much related to both functions. They all do the same kinds of things. Okay? So what did H and K do for us before? They gave us the vertex. Guess what they do here? They give us the vertex. Okay? So if somebody gives me the equation in this form, I'm not going to start by finding anything else. I'm just going to start by finding the vertex. Okay? And now that I know that negative b over 2a thing, I would probably start that way in standard form too. Okay? But the H and K immediately give me the vertex, which means I also know the number associated with my axis of symmetry equation. Then to get the solutions or to get any other points on the side, you can either plug in or you're going to have to get these solutions by solving a specific way, and we're going to talk about different ways of solving the quadratic. So our focus is going to be on understanding how the equations work and getting them on the graph, but then also being able to do algebra with them to find all these other things that we might want to find. Okay? All right, so what you guys should have in your notes then right now is you should kind of have like a summary of the important parts of the parabola and the different types of forms that we're going to see. Okay, so your parent function, okay, like Matt asked, what is the parent function? Since we're dealing with quadratics, the parent function is y equals x squared, because it's the most basic quadratic without anything being added, subtracted, or multiplied to it. What does that quadratic look like on the graph? What does x squared going to look like when you graph it? Good. It's going to have 0, 0 as a vertex. Okay. So 0, 0 is the vertex. I know that two ways, either because of the vertex form that we just discussed or from my work with quadratics. Does it open up or does it open down? Up. And then it's a little bit different from absolute value in the fact that growth of a quadratic is not uniform, or else it would look just like an absolute value. It would have lines for sides, okay, and it would be like a V. Instead, when you go over 1 unit, you go up 1 unit because 1 squared is just 1. But when you go over 2 units from the vertex, okay, 2 squared would actually be 4. So we would actually go up 4 units. 1, 2, 3, 4. Okay. 2 units over, 4 units up. And then we would have our U shape. Okay, not a V shape, a U shape, or a parabola. Okay, so the vertex is 0, 0, which means the axis of symmetry is at x equals 0. It opens up. And then in the transformation column here, you can see it says this is the parent function. So there are no transformations from the parent function. But if something's being added, subtracted, or multiplied, you should be able to look up what kind of transformation that is and fill it in. Okay? Any questions about that? So your goal is to go ahead and fill in the rest of the chart. Okay? Okay, before you leave, eyes up here quickly. I want to talk about this last question at the bottom that I wrote at the bottom of the chart. The transformations that take place when all of this is going on, to review your transformations a little bit. So here, there's a multiplier in front of the squared factor of -4. There's a +5 inside the factor that's being squared, and there's a +3 outside of the factor that's being squared. Somebody explain to me one transformation that is occurring. Okay, good. So there is a reflection, you could say, over the x-axis, or you could call it a vertical reflection because of the negative. Okay, Cody, what else?
It's translating right 5 spaces.
Okay, so it is being translated. It's not actually moving to the right, because what is the value of h in this case, Alex? It's actually -5, so we're going to the left 5 spaces. And that has to do with the minus h part of the parentheses. What else? Helen? Good. It is going up 3. So it's going to the left 5 and up 3. We've accounted for everything except for the 4. Raven? Good. Because the 4 is happening outside of the squaring, it's a vertical change, and because it's greater than 1, it's a stretch. Okay? All right, check Canvas for your homework because it may...